In our previous videos, we have been talking a lot about indefinite integrals, and these are integrals that have an arbitrary constant c. And now we'll be taking a look at definite integrals in which there are limits. Okay, so we have the upper limit and we have the lower limit. If we have an expression like this, x, b, and a. The b is known as the upper limit and the a is known as the lower limit. So the operation of applying the limit is simply saying that this expression will be, wherever we see x we substitute b, and wherever we see x we substitute a. So therefore we are saying upper limit minus lower limit. Let's take for example, we are asked to integrate x squared with respect to x from the limit of 1 to 3. Now the first thing to do is to integrate x squared, and integrating x squared we will have x cubed divided by 3, and we'll still apply our limits 1 and 3. Now we notice that we do not apply any form of arbitrary constant c, because in this case we have definite integrals. We have the lower limit and we have the upper limit. Now, having done that, we consider the upper limit. The upper limit is 3 and the lower limit is 1. So we know that it is upper limit minus the lower limit. So wherever we see x, we substitute the upper limit. So that is 3 raised to the power 3 divided by 3 minus, wherever we see x, we substitute the lower limit. And the lower limit is 1. That is 1 raised to the power 3 divided by 3. Now this will give us 27 over 3 minus 1 over 3. And an expression here should give us 9 minus 1 over 3. And this is 8 raised to 2 over 3. Let's take another example. Let's integrate 3x with respect to x from limit of 1 to 2. Now the first thing to do is to integrate 3x. And integrating 3x, we have 3x squared over 2. And we apply our upper limit and lower limit, that is from 1 to 2. Therefore, we substitute our upper limit first. That is 3 into 2 squared minus 2 minus, we substitute our lower limit, which is 3 into 1 squared by 2. So simplifying this, we will have 3 times 4 over 2, 3 times 1 over 2. And this is 12 over 2 minus 3 over 2. This is 6 minus 3 over 2. And it will give us 4, 1 over 2. Let's take another example. We are asked to integrate from minus 2 to 3, 4 minus x squared dx. Now we can see this is definite integral. So we are going to simplify. We'll first integrate 4 minus x squared with respect to x. So integrating 4 minus x squared with respect to x, that means we are integrating each term. So integrating 4, we'll have 4x, and integrating x squared, we have x cubed over 3. Then we put our upper limit and lower limit. And that is minus 2 and 3. Now, having done this, we substitute our upper limit and we substitute our lower limit. We know that the upper limit will come first and the lower limit comes later. And the upper limit in this case is 3. The lower limit in this case is minus 2. So let's substitute our upper limit. So wherever we see x, we substitute 3. 4 into 3 minus 3 cubed over 3. Close the bracket. Subtract again. So wherever we see x now, we substitute our lower limits. So we have 4 into minus 2 minus minus 2 raised to power 3 over 3. Now when we simplify this, you will have 8 1 over 3. Let's take another example. 4. We are asked to integrate from 0 to pi over 2 of 3 sine 2x with respect to x. Now the first thing to do is to integrate 3 sine 2x, and after that we impute our upper limit and our lower limit. So let's solve. 3 is a constant, it can be brought outside the integral, and we'll have 0 over 2 sine 2x dx. Now let's take a quick recap. When we are asked to integrate sine at with respect sine ax with respect to x, we will have minus 1 over a cos ax. Therefore, when we integrate sine 2x and our a is 2 in this case, we'll have minus 1 over 2 cos 2x. We are integrating from limit of 0 to pi over 2. Now the upper limit is pi over 2, the lower limit is 0. Therefore, we can open this bracket now and say this will give us minus 3 over 2 cos 2x 0 to pi over 2. So let's substitute our upper limit. So we have minus 3 over 2 cos 2 into pi over 2. And then let's substitute our lower limit. And that is minus 3 over 2 cos 2 into 0. Having done that, we simplify further. This will give us minus 3 over 2 cos pi minus into minus 3 over 2 cos 0. Now cos pi is minus 1. That's minus 3 over 2 into minus 1. And cos 0 is 1. So simplifying further, we have this to give us 3 over 2 minus into minus 3 over 2. Therefore, this will give us 3 over 2 plus 3 over 2, and that will give us 3. Let's take another example. We are asked, this is example 5. And now we are asked to integrate from limit of 1 to 2 of 4 cos 3t dt. Now in this case, the first thing we will do is to integrate cos 3t. Integrating cos 3t, that means we are going to integrate cos at dt, and this format we are going to have it that to give us 1 over a sine at. And we can bring the 4 outside as a constant. 1, 2, and integrating cos 3t dt, we'll have 1 over 3 sine 3t from 1 to 2. Now this will give us 4 over 3 sine 3t multiplied from limit of 1 to 2. So the first thing we will do is to substitute our upper limit. So putting our upper limit, we'll have sine 3 into 2 minus our lower limit, which is 1, and we substitute it into t, and that gives us sine 3 into 1. So this gives us 4 over 3 sine 6 minus 4 over 3 sine 3. Now sine 6 here, 6 here is in radians, 3 here is also in radians. So when you plug in into the calculator to evaluate radians, so we'll have minus 3. This will give us minus 0.37255 minus 0.18816. Simplifying this, we'll have minus 0.5607. Now we will be able to look at how to perform definite integrals. In our next video, we'll be taking more examples on definite integrals.